All right. Now there are times when you know that you know something and you cannot get it back out. I just had this in class the other day. I heard something on my way into class and I said to myself, oh, this is completely relevant to what I'm going to be talking about today. Don't forget. So I walk into class, I start to lecture, I remember the thing I want to say, but I go, oh, I don't want to say it yet. So I said to my students, I go, oh, I saw something, I heard something on the radio. Don't let me forget to tell you guys. Then I got to the part where it was totally relevant to talk about it, and I literally 100% could not remember what it was. I sat there and stared for a few seconds and tried to visualize myself driving in the car and what was I listening to and what could I possibly have heard? What in the heck am I looking for? I could not remember it during that class period. I didn't remember it on the drive home. I'm driving back to school the next day when context is back to what it had been when I heard the original story on the radio. And all of a sudden it came back. Luckily I had a carpool partner, so I said, get a piece of paper, write this down for me. So finally the memory came back. Unfortunately, it's a class that only meets once a week, so by the time I saw them again, an entire week had elapsed. But now I have it written down, and so I was able to do it. But it's funny that it was clearly in my memory. I just could not retrieve it. And that's what is so mysterious about memory. You know it's in there and you can't find it. Or you thought you got it in there. Where'd it go? Okay, there are different ways that we retrieve information from our memories. One is called recall. That is where, like I was trying to do, I had something stored in my memory and I was trying to generate it with very minimal cues, right? I was just trying to remember it. If I were to ask you, what's your phone number? First off, it'd probably be pretty funny because you'd probably say, I don't know, let me check my phone. Which is kind of funny because most of us, in the olden days had our phone numbers memorized. When I think about my own cell phone number, it's like, what is my cell phone number? I don't even know my own kids' cell phone numbers. How pathetic is that, right? If I lose my cell phone, I can't call my own children. It's pretty stupid. But we've all kind of just become dependent on that sort of thing, right? We don't have to recall things like that anymore. We don't have to be able to generate a 7-digit or 10-digit number with area code, right? Recall's hard because you have to generate options and pick among them. So when somebody asks me what's my phone number, theoretically my brain might be going through all the different phone numbers I've ever had in my life, and I have to recognize which one or recall which one is the correct one. So it's like a two-step process. Generate alternatives and then decide which one's right. Whereas recognition is a one-step process where I show you some alternatives and then you recognize which one's correct. Which, would be so much easier to recognize your own phone number out of a list of numbers, right? So it takes a lot less cognitive effort. Okay, I have to tell you, in my classes, I'm sorry, when it's online, it's harder to do everything, and I can't figure out a way to have you have this experience because I don't know how to mute this screen. What I normally do in class is I mute the screen that's projecting on the wall, and I then read these words, skipping over the word needle as I read the words. And I tell the students I'm going to read you a list of words, try and remember them, and at the end you're going to write down as many as you can recall in any order. So I read them out loud, skipping over the word needle. So I read out a total of 14 words, and I tell them to remember as many as they can. And they all can generate somewhere between like 5 and 7 items generally. With a really crazy memory, you might get 10 out of somebody. And then I show them the list, and I tell them, okay, some of these words were on the original list and some were not. Now, of course, all of them were on the list except for the word needle. And so then I ask them to recognize which ones that they know for sure that they saw before and which ones they think are new. First off, their recall lists tend to be pretty short because free recall is tough. They'll write down maybe 5 or 7 words and then they're tapped out. They can't remember the rest. When I turn on the list and show it to them, they usually are able to accurately recognize almost all of them. But what's funny, and I'll come back to this list, is they don't necessarily all agree on which ones were not on the list. I tell them, all but one was not on the list, and they disagree on which one it is. So we'll come back to that in a little bit. So to know whether you hold something in your memory, we can try and get you to recall it, we can try and get you to recognize it, or we can see if it's a task that can be learned faster the second time, or content that can be learned faster the second time. When you display rapid relearning, we call it, that's an indicator that you had it in your memory. Some of you might have had this experience if you took a foreign language in high school, and then when you came to college, you were like, maybe I should just start at the level 1 because I don't remember that much. I'll just start over again. I won't try and bring in my high school stuff. And so you take the class over and you're like, wait, I must remember some of this because I learned this a lot faster than I did. I mean, in 1 quarter in college, we cover an entire year of high school foreign language, and you're keeping up, right? It's like, oh wait, I must know something. That's what we mean by rapid relearning. Ebbinghaus, who was a really early researcher in memory, used a little test where he taught himself a list of nonsense words. They were just consonant, vowel, consonant, made-up words. And he practiced them and rehearsed and tried to remember them. And then he retaught himself the list. And what he found is that he got to, so we have on the x-axis how many repetitions it took him to get to a particular level of competence on the first day that he encountered the list. And then on the y-axis we have how much time it took him to relearn the list on day 2. And what you see is that the more repetitions he did on day 1, indicating presumably the deeper he encoded the information, the less time it took him on day 2. So if you know it already, then you'll relearn it faster, even if you don't really think you know the material. Okay, I found this really awesome picture on the internet of kind of like the concept of taking the dog for a walk and the neural network that is associated to that concept, right? So there's some things that are directly related, like taking a dog for a walk includes the location of being outside. A person obviously must be there, right? And there's probably a leash if you're taking the dog for a walk. And there's got to be a dog. There's the implication that the dog's in front of the person, although the dog whisperer says he should be next to you. But anyway, right there, so there's the hard connections among those things that are sort of implied and assumed to be true about the situation. And then the dotted lines are the kinds of things that you might be triggered to think about because you're thinking about taking a dog for a walk. It might lead you to ultimately be thinking about grass, or it might be leading you to think about tricks that the dog can do, like sitting, or movements that other animals can do, like flying. And right there, you might start to think about cats because your brain might at least start to think about cats because you thought about a dog. That's kind of how retrieval works, that if you have a good cue, it'll take you down the hard lines where it'll take you to what you're looking for. If you have poorer retrieval cues, it might take you off onto the dashed lines and cause you to retrieve things that are unrelated to what you're trying to find. And that's the dicey part about memory, is that you're really reliant on whatever is prompting you to think about the information. One thing that'll prompt you to think about the information is priming. So retrieval is affected by whatever has activated our associations. So here's a nice picture of a tree. Very nice. So if I have shown you a nice picture of a tree and then ask you to define the word bark, you might be more likely to use a tree-related definition than if I were to show you this picture and define the word bark. Now, of course, here's what's funny about this particular setup, because I pulled this off the internet for its shape and its elaborateness more than its content. So the first time I used these slides in front of a in-person class, it didn't even really occur to me that I'm talking about a dog. Then I show you a tree and I tell you define bark. They're all like immediately going to dog barking because the tree just looked like decoration to them, because I'd already primed them with dog. I primed them with dog when I gave the semantic neural network on the previous slide. And I hadn't even really thought about it when I prepped the slides that I had pulled an example that involved the word bark. Is bark even on this slide actually? Let's see, is bark on here? No, I don't see bark, but it's kind of implied, right? So that when I prime you with this, you actually were not primed by seeing that tree. You were primed by seeing that neural network of a dog going for a walk. So that's what I mean accidentally by priming, right? Is that, so what I need to do on this slide is switch the two pictures, right? So that first you got the dogs, since I already have you thinking about dogs, and then I switch to tree. That's what I'll do for the next class. They'll see it in a different order. I just thought of that. Okay. So anyway, so what you're thinking about in advance will prime you to sort of think about, be more readily able to retrieve things that are related to what you were already thinking about. That's basically the idea with priming. Another thing that can affect your ability to retrieve information is the context in which you learned the information, the context in which you're trying to retrieve the information. We call this context-dependent memory. We retrieve a memory more easily when we're in the same context as when we formed the memory. I don't know if some of you are taking notes while I talk or not. If you are, you can always hit the pause button, because I kind of go fast because I'm talking to myself and I can't see you guys reacting. So we retrieve a memory more easily when we are in the same context as when we formed the memory. Okay. One study showed, okay, this is an old study that's really a classic, and their original hypothesis was that it would always be harmful to your memory to be under stress when you're trying to remember stuff. So their original hypothesis was that if you learned a list of words on land and then got tested underwater in your scuba gear, that you would remember fewer words than if you were taught the list of words on land and then were tested on land. And they were focusing really just on that stress of being underwater for retrieval. But they were good researchers because they didn't just do those two conditions. They went ahead and did a full balanced design where they had some people who learned the list on underwater and then got tested on land. Some who learned the list on land and got tested underwater. Some who learned the list underwater and got tested underwater. And some who learned the list on land and got tested on land. They were a little surprised when they found that what mattered the most was having a match between where you learned the list of words and where you retrieved it. The green bars show us that when there's a mismatch between where you were when you learned it and where you were when you retrieved it, you do much more poorly than when there's a match between those things. Now, of course, being underwater at learning and encoding produced poorer memory than if you were on land for both, right? So, they did like 25% worse when they had to be underwater for both things, but they remembered roughly half as much when there was a mismatch than they did when learning and recall occurred on land. So the idea is maybe we are storing along with the important information, maybe we're storing along with that some context, right? Something about our environment that helps it to cue our memory. That's what we mean by context-dependent memory. Something about the environment is helping us to recall things. One of the best pieces of advice that I can give students is to study in the same context that you're going to retrieve the information. So if you can set it up so that you study in the same place that you're going to sit down and take your midterm, you're going to do better overall than if you study in one place and then actually sit down and try and retrieve the information in a different place. There's something about the setting that you encode that actually facilitates memory when it matches at retrieval. So do the best you can to do that. Now there's another part of context that it actually gets separated out and gets treated differently, which is what we call state-dependent memory. Mood is a state, and it can serve as a context. So if you're really happy, or you're really angry, or if you're depressed, that mood gets encoded along with the material and can affect how well you retrieve the information. when there's a match between your mood at encoding and your mood at retrieval, you'll remember better. So if you're really mad while you're studying, then you should probably be really mad while you take the test. I don't know how you would achieve that goal, but that's the basic idea, right? Um, Mood congruent memory is what we're talking about here. You want to match, you want to be congruent in your mood between encoding and retrieval. So whatever that takes, it makes for better memory. It makes it easier to retrieve information when your mood matches. Now, mood-dependent memory is a little bit different. Mood-dependent memory says that we really focus on and pay attention to those aspects of the environment that are relevant to our mood. And so we actually remember better those things that go along with the mood that we're in. So you might have had the experience where maybe you broke up with your romantic partner, and then it seems like every song on the radio or Pandora or whatever you listen to is about love. And you're like, what is wrong with the world? Why is everybody talking about love? I just broke up with someone. What is this? We tend to focus on and notice those things that are consistent with the mood that we're in, and they are more likely to be encoded and more likely to be retrieved later. Now the thing is, I don't have great data that supports this. The study that really showed that this happens was never really replicated. Nobody else was able to show that same effect. But it's such a robust effect in our lives, like we can all relate to it, that it's hard to discount. It's probably true. So mood definitely affects what we pay attention to and encode, and then it also serves as context for retrieval. Other states also serve as context. So if you're drunk, that's part of the context that gets stored along with the memory. And so when you're drunk again, you may retrieve aspects of the memory that you had forgotten while you were sober, like where you left your car keys and things like that. If you're really tired, that can serve as context. If you're high, it can serve as context. So again, you want to match your mood or your state at learning and at retrieval, right? So if you're studying for class, you want to try and be well rested, and then be well rested for the exam. I guess the flip side is be really tired both times, but tired, it's like being tested underwater in both conditions. It's good to have it match, but it's better to have it match in the advantageous way. So, not drunk or high or tired is better than making it match and being drunk or high or tired. All right, let's go ahead and stop here, and we'll come back in the next segment and talk about forgetting. We'll start with amnesia.